So good afternoon everybody, myself Acharya Vishwan, and let's discuss today NCRT questions. So the present chapter that we are going to discuss is about chapter 11, which is related to temperature and heat. So let's begin with the questions. So here are the questions. So the first question is about temperature, then boiling, freezing, then hot and cold, then we have concept for heat transfer, then ice cold water, then about heat, SI unit, temperature, heat, commonly used properties, uh, gas thermometers, standard scales, absolute reference, ice point, stream point, ice point at centigrade scale, stream point at centigrade scale, number of divisions on centigrade scale, on Fahrenheit scale. Then we have some graph related questions. Then correspondence between AB and C points, tan theta, mathematical relation. Then liquid in glass thermometer. Then we have glass thermometer. Then Boyle's law, graphs, Charles law, graphical variation, density versus temperature, ideal gas equation, universal gas constant, its dimensions, SI unit, absolute zero, 1 Kelvin scale, absolute zero, Fahrenheit scale. Then we have size of unit is same for. Then relation between centigrade Kelvin scale, then metallic lids, thermal expansion. So balloon under room temperature is brought near hot water. So impact of that. So impact of heat on volume of air, and impact of heat on various substances, increase in dimensions, areal expansion, longitudinal percentage change, fractional change, coefficient of linear expansion, dimension formula, SI unit, then values of coefficient of linear expansion. Then volume expansion, then we have gauge pressure and absolute pressure. Then we have surface energy, dimensional formula for specific gravity, etc. Then we have coefficient of volume expansion, variation with temperature, dimensional formula, SI unit. Then values of coefficient of expansion, expansion of heating. Then we have coefficient of volume expansion for liquids, then graphical variation of volume expansion, then path dependent function, path independent function, work done under constant pressure, boiling of water, heat capacity, dependency on different things, dependency of a specific heat capacity, molar specific heat capacity, molar heat capacity of solids, then it is least for molar heat capacity is 3R. Then we have variation of a specific capacity of heat capacity of water. Then definition of 1 calorie. Then we have a rapid expansion of water, of gases. Then we have diathermic walls, then thermodynamic state variables, then pressure volume curves, then extensive state variables and intensive state variables, mechanical and thermal equilibrium of a gas. Then we have questions on heat, quasi-static process. Then we have approximations to quasi-static process. Then we have constant temperature process. Then we have isobaric, isochoric, adiabatic process. Then graphs of isothermal process, work done in isothermal, positive and negative work done, zero work done, various relations corresponding to different processes like isothermal, adiabatic, compression, expansion, adiabatic process, adiabatic expansion, compression, the characteristic equation of an adiabatic process. Then different processes in the same graph, questions are being asked on the work done in adiabatic process. Then we have work is done by the gas, work done on the gas, work done in isochoric process, isobaric process, cyclic process. Then we have concept of heat engine, then working substance of steam engine. Then we have a heat engine numerical based on that. Heat absorbed, heat taken, rejected, work done, efficiency, fundamental efficiency on fundamental limit on the efficiency of heat engine. Then we have external furnace, internal furnace, refrigerator. In the refrigerator, transfer of heat, cooling of gas, second law of thermodynamics, Kelvin-Planck statement, Clausius statement, spontaneous process, irreversibility, reversible process, maximum efficiencies for which process, irreversibility is concerned with heat absorbed and heat released in a process. Adiabatic processes, working substance in a Carnot engine, efficiency of a Carnot engine. Then we have relation between heat and temperature in Carnot engine, then the above relation, then a universal thermodynamic temperature scale, then we have zeroth law of thermodynamics, then first law of thermodynamics, then we have questions based on the graph of heat absorbed versus change in temperature, definition of 1 Kelvin, state variable of a thermodynamic system, then we have concept of a refrigerator, reversible process, idealized reversible process, Carnot engine. Concerns for delta Q is positive, negative, zero, conditions for positive work done, negative work done, temperature relation to what, bullet, then equilibrium in thermodynamics, then equilibrium of system in mechanical forces, then the macroscopic constituents, then heat capacity, then in last isothermal quasi-static process. So these are the questions from the chapter, and they help to optimize your energy and time. So I hope it will optimize your time and energy and enable you to perform better in exams. Thank you and have a nice day.